Good morning, good evening, and good night to all the audience that are watching this video. We are students of Diploma of Electrical Engineering from UTEM. Now I'm going to explain the step-by-step calculation for this circuit. The method we use for analyzing the circuit is nodal analysis. First of all, we must assume the direction of current. So here is the assumed direction of current. From the assumption, we know that I total is equals to I2 plus I1. And I1 is equals to I6 plus I5. From there, we know that I total is equal to I2 plus I6 plus I5. Now we must find I total to eliminate one unknown from two unknowns in the equation. So the first step of finding I total is converting the circuit into an equivalent circuit. But before doing that, we must convert the value from time to phasor. So here is the step to convert time to phasor. From time to phasor, resistance stay the same, but capacitance will change according to the formula. Inductance will need to be converted as well. Here we can see that resistance is parallel with inductor and capacitor is parallel with one resistor also. And it is in series with a resistor. After that, parallel the whole thing. After finding out the equivalent impedance of the circuit, we must use the formula I total equals to V over Z equivalent to find out the value of I total. Now we can use the method of nodal analysis to find out what is the formula for each current. Here you can see the before and after of the equation. So from the equation, we can find out what is the value of voltage from node 2. Here we can see that the voltage at node 1 is equal to 100 volt with 0 phase angle. As for the voltage of node 2, it is equal to 49.4003 with phase angle of negative 8.8970. We converted all the peak value to RMS value because the simulation is done in RMS value. Now, using the formula that we found out from using a nodal analysis, we can find out what is the value for each current.
So now the explanation of power analysis on what is the value of real power, reactive power, and apparent power. So in this case, we are using complex power formula because that is how we are going to get the value of P, Q, and S. The formula is S equal to VRMS multiplied with I total RMS. So the value of apparent power will be this value. So the value of the real power is equal to 7559.7057, and the reactive power will be equal to 7575.7405. The overall power factor formula is P divided with S, which is the value that we just get, and insert it into this formula. So the power factor will be equal to 0.7064. So this is power triangle diagram, and this is phasor diagram. Next is to apply a suitable power factor correction to improve the overall power factor. We want to find a new reactive power, so we need to use a reactive power formula, and that is real power multiplied tangent multiplied with angle. Angle value is equal to 0 because inverse cosine multiplied with new power factor, and that is 1, will be equal to 0 degree. Next is to use new reactive power to find a reactive power of capacitor, and that is equal to old reactive power and new reactive power. After that, use reactive power of capacitor to find a impedance capacitor and convert it to a value of capacitor. and the value of capacitor is 4.8229 millifarad. So a 4.8229 millifarad capacitor will be added in parallel to the circuit.